Thanks for waiting patiently. I am not the astronaut, but I am the lucky one who gets to introduce the astronaut. But before I get to introducing the astronaut, and while people are sitting down, how many attended the astronaut Q&A session? Such amazing questions, such insightful question by the kids. It was just inspiring, actually, to see such young folks have such insight and such just ideas to ask and really innovation in their heads. So it was really inspiring to see. Again, my name is Rajan Bose. I am a Senior Director of Engineering at Yahoo, and I'm also a member of the Yahoo Employee Foundation. I am one of the lucky ones who was able to champion the grant that brought some of the funds to bring these type of events like STEM Central to the Santa Clara libraries, as well as other STEM events that are happening throughout the various branches of the Santa Clara City Libraries. And as I said, I am the lucky one to, thank you. I am the lucky one that does get to introduce our next guest, our next guest speaker. She is, oh, sorry, I hear the music coming. She has received her Bachelor of Science from UCLA in Aerospace Engineering. She received a PhD in Oceanography from UC San Diego, and she did her graduate studies at the Scripps Institution of Oceanography. She she has actually held various roles at NASA, including as mission specialist aboard STS-125, the space shuttle mission, the last space shuttle mission to go repair the Hubble Space Telescope. And specifically, she was the one who operated the robotic arm, grabbed the Hubble Space Telescope, and popped it into the cargo bay so the other astronauts could work on it. I know Megan also not just through this, but I know her through some mutual friends of ours, and I just have one anecdotal story of how inspiring she is to me before I bring her aboard or onto the stage. And my family and I last year went to Johnson Space Center, and we did one of the tours at Johnson Space Center in Houston. And on one of the tours, you actually enter Building 9. It's the Space Mock-Up Vehicle Facility, SVMF. And it's a very large facility where they have life-size replicas of the space station and other types of vehicles that they'll be using or have up in space so they can do various things on it in a lifestyle fashion, in a real scale fashion. And in that facility, you're walking as a visitor, you're walking in this catwalk kind of above on the second story, looking at this massive area of all of these space vehicles that we have there. And there happened to be one place in that area where they had a table, and there was a lady there. She was at a computer, seated down. She was basically commanding an audience of other senior scientists there, going over various things. I'm like, that was pretty inspiring. I looked at all these men that were men and women looking at this one individual who was clearly going over some important stuff. And I was inspired by that, but then I kind of looked at her. I'm like, hey, I know that person. This is really looking second floor down, probably about 40 yards away. And I turned to my wife. I'm like, is that Megan? And my wife, who also knows me, that is. And instantly I turned into Mr. Paparazzi. It turned out my camera, I have like a 300 millimeter zoom lens. I was like, so awesome to see how she can command such an audience. So again, it is my honor and my pleasure to welcome our next guest speaker, Dr. Megan MacArthur.
Don't be alarmed by my escort. They appear to be friendly to the Rebel Alliance, so far as I can tell. So that was really cool. It's fun walking around with your own hero music. It's pretty neat. So I hear it in my head. No, I'm just kidding. Wow, this is awesome. Thanks, everybody, for coming out to hear about NASA today. I'm really excited to be here. I have some family here, as you maybe have already learned, but and some friends as well. So I'm from this area, so it's always a treat for me to come back home and talk to friends at home. We'll see if this works or if I have to go the old. I don't know why I'm pointing at the screen. Yeah, apparently I'm not good with technology, so we'll just go this the old-fashioned way here. So here's what we look like from space. I took this picture, and we didn't go directly over the Bay Area. That's why we're kind of an oblique angle here, but this is home sweet home for me. Unfortunately, I don't live here. Currently, I live in Houston, but this will always be my home. I went to school in the local area. This is me and my sister. Erin is right here. Doesn't quite look the same either. And this is me in high school, so Mountain View High School. And then I went to St. Francis High School, graduated from St. Francis with my friend Maureen, who is somewhere in here as well. So, these are my roots. This is my hometown. So I'm a NASA astronaut. I have been there for almost 17 years, and I flew in space aboard this space shuttle. This is Space Shuttle Atlantis, launching from Cape Kennedy there in 2009, May 11, 2009. And it was a pretty awesome ride. And so I'm going to tell you a little bit about my own background, and then we'll talk about what's going on now in the space program. I went up to fix the Hubble Space Telescope. Who's heard of the Hubble Space Telescope? Anybody? All right. This is a good crowd. So the Hubble Space Telescope makes these awesome images that are not just screensavers. They're real science is happening here. This image was taken as a birthday present for Hubble, or from Hubble, really. Hubble's been in space now for 27 years. Just had the birthday or the anniversary, if you will, this week. 27 years in space. So this picture was taken this year. These are two spiral galaxies, and so this is a neat view of what our galaxy might look like to an observer from somewhere else in the universe, depending on their angle. So here's one edge on, and here's one more facing on, but I like that image for that reason. So this is some kind of fun facts about the Hubble Space Telescope. It was really neat for me as a scientist to get to participate in repairing something like this that is so much larger than any one person or any one group of people. You can see the enormous amount of return that we've gotten from it in its history. And so it was really, like I said, a really neat thing for me as one single person to get to be a part of something so amazing. And we're going to keep learning from the Hubble Space Telescope for years to come. As it unlocks the mysteries of the universe. This is a picture of my crew. There we are in space, and on the right side there, that's what the Hubble Space Telescope looked like. It was my job to capture the telescope and bring it into the payload bay. And so here's a picture of me hard at work. I'm strapped in here. I was also the flight engineer, so during launch and landing, I helped the commander operate the space shuttle and respond to any emergencies. And then the other picture, you see me operating the robotic arm. So basically, I'm looking out. It's like if you can imagine in a pickup truck, if you were looking out the aft windows in your pickup truck into the bed of your pickup truck, that's kind of like what I'm doing right here. So looking into the bed of the shuttle, we call it the payload bay, and I have we have the telescope back there. I'll go back one so you can see that again. Oh, now it's busted. There it is. So there's the telescope on the end of the robotic arm after I've captured it, and then I place it in the back of our payload bay, and then we open up the doors and did all the repair work that we did over a series of 5 spacewalks. So we were in space for about 2 weeks. We went around the Earth 197 times while we were doing our repair work, and it was a pretty amazing mission. And after that mission, the telescope we repaired some instruments, and then we upgraded some instruments, because you can imagine 27 years ago, hey Rory, good to see you, sorry. You can imagine that technology that's 27 years old, it needs to be upgraded, right, if it's still going to be doing cutting edge science. So that's what was really unique about the Hubble Space Telescope, is that it was designed to be serviceable by astronauts so that we could continue to upgrade its capabilities over the years, which is what we did. So sadly for me, this was my only flight so far, and because it was right near the end of the space shuttle program, you probably know that the space shuttles were retired in 2011, and we haven't flown any space shuttles since then. So this is one of my favorite images that I took on our flight. Right at a sunset, I was just getting ready to put away the robotic arm, and we were just coming into sunset. So that was a neat picture, kind of symbolizes the end of that good couple weeks in my life. The orbiters have all been given out to museums now. So they're all on display at different places. I hope sometime you get a chance to see them. It is definitely a little bit sad, though, for me when I go to a museum and see one, because I wish that we were still flying them. But this is kind of a neat photo as well, seeing this one go off to its new home in a museum, being piggybacked across our capital there. So what are we doing if we're not flying the space shuttle? Well, we still have astronauts that live and work in space every day. They're up there right now. We have 5 people living on the International Space Station right now. 2 of them are Americans. And they're up there doing scientific research. So they're doing all kinds of different research on the body, on physics research. Right now, the commander of the International Space Station is a woman named Peggy Whitson. It's her 2nd time as the commander and her 3rd time in orbit. She's spent 3 6-month stints up there. She's into her third one, and she'll actually stay close to a year this time. So she's a pretty awesome person. She now has the record for the most time in space by a U.S. astronaut, not continuously. She did get to come home in between those missions, but up to 539 days today and counting, which is pretty awesome. She just broke that record this week, actually, earlier this week. And she also has the most spacewalks by any woman astronaut, so she's done 8 of them. So you can see a couple of the different things that she's doing that she might do on a typical day in space. So here she's actually fixing the air conditioner, essentially. So it's called a Cedra. I don't know what happened. We're back. Okay. So carbon dioxide removal assembly. So it periodically conks out and needs some maintenance or just needs some work done on it. And carbon dioxide removal is obviously very important to us living on the space station and any mission that we would take long distance beyond Earth. So this is the kind of thing, technology demonstrations, improvements to this kind of technology where you can live and work in a closed system for a really long period of time. We're breathing out carbon dioxide all the time. And in here, it doesn't matter unless we really sealed up the room. Then we would all get tired pretty quickly. But in space, it's very important, and you can start to feel effects, headache, dizziness, just general hostility to the world if you get too much CO2. In the center picture, of course, she's getting ready to do a spacewalk. She's buttoned up in her EMU there, Extravehicular Mobility Unit. We do love our acronyms at NASA, EMU. So she's getting ready to go outside and do some repairs on the outside of the space station, which is another important thing that you need to be able to do, repair your home effectively. If you have to go outside and change a circuit breaker, well, in space we have to put on a spacesuit before we do that, and our circuit breakers are a lot bigger. So, and then in the top corner over there, she's working on an experiment called Veggie, where we're growing vegetables in space. And right now it's still kind of experimental. We're not growing them for food at this point. One of the things you have to worry about in this kind of environment is that everything, including any bacteria that you might have brought on board, is going to be floating. And so it could end up landing on your food, and we don't have a sink that we can go over and wash the lettuce in. So we have to think about ways, how could we identify what the microbiome is, what might be hazardous to us on the food that we're growing in this enclosed environment. So one of the ways that we might be able to do that in the future is an experiment that was done last year. This is Kate Rubins. She's come home already, but she was the first person to sequence DNA in space. That just happened last year with the MinION, a small DNA sequencer. And just as a side note, if we have time to talk about it later, I actually got to preview that experiment when I was living underwater for 2 weeks in a habitat off the coast of Florida. So we looked at how you would run this experiment, what would be the challenges in an enclosed environment, and looked at how you might actually sample the environment. The DNA that she sequenced was pre-sampled for her, but we had to actually collect the sample in our environment. So that's something eventually you could do on space station if you wanted to check the cleanliness of your environment. Right now we have to send those samples back down to Earth to identify what might be out there. So this is something that we might be able to do in future. But you could also look at it for human health, right? You could look at human DNA. We don't do that yet, but you could, in theory, do something like that and look at what are the changes that are happening, what are the genomics that are changing from the effect of living in space. I'm going to go through some of this quickly because they did want me I know we're running a little bit late, but these are some of the representative of some of the kinds of research that we're doing in space. Space and microgravity is hard on your body, and if we're going to be living long distances, long term, away from our home planet, then we need to understand what those changes are and how we can potentially mitigate them. So this is my good friend Karen. She's actually checking out her eyeball because we have some vision impairment problems that we don't completely understand why those take place on some people and not on other people. This is a view of somebody exercising. So your muscles and your bones deteriorate when you live outside of the effect of gravity for long periods of time. And so we have to counteract that so you can still walk and function when you come home. And so this is a way to do resistive exercise. You can't lift weights in space, obviously. So this is a way to do squats and other load-bearing exercise to keep your skeleton and your muscles strong. We also have a treadmill. This is Joe is doing some fluids experiments. As you're building new spacecraft, new types of combustion, you need to understand how fluids are going to work in microgravity. And this is another materials experiment that you want to know, as new materials are developed on Earth, are these things that we can use for new activities in space and away from our home planet. So how do we get to the space station if we're not using the space shuttle? Does anybody know? Soyuz, yeah, I heard a couple of people say it, Soyuz. So the Soyuz rocket lifts off from Kazakhstan, and so our American astronauts and all of our European and international partners, Japanese, Russians, everybody launches on this rocket right now. It's the only way into space. We would like to change that. We'd like to return the ability to launch people from this country. So right now we are working with, so cargo, we used to send cargo up on the space shuttle as well. We can't do that anymore either. These are unmanned cargo vehicles. So we currently have the ability, two US companies, one is called Orbital and one is called SpaceX here in California, Southern California. And these are unmanned cargo vessels that fly up autonomously to the space station, and then the astronauts on board use a robotic arm, similar to how I grabbed the telescope, reach out, grab this cargo vehicle, plug it into the side, then they can unload all their food and new equipment. So we do have that ability to launch from the US. And we are working with two companies. Again, one is SpaceX and one is the Boeing company, to build the capability to send people from this country, again, to the International Space Station. So these capsules are much smaller than what the shuttle is, but we can send about 4 people on either of them. And hopefully we'll be launching those in the near future. This is the Dragon vehicle. And we're close enough that they've named the next crews that will fly up on each of these vehicles. So these are the 4 folks whose names you'll see hopefully in the next couple of years as being the first to go to the International Space Station on these new vehicles. And so the reason that we sort of outsourced the local communication, the local travel, if you will, kind of the taxi flights, is that NASA engineers are working on developing sort of I call it exploration class vehicle and rocket, a really giant rocket, and a capsule called Orion that can go beyond low Earth orbit, that can go into a moon orbit type of a thing. And so that would be, this is a kind of a picture of the vehicle and all of its different pieces. Again, I'm going to kind of go through that quickly. And so where we are in this flow right now is they're going to launch a uncrewed rocket, hopefully next year, and that will go around the moon. And then by hopefully 2021, we'll be able to launch people and put them in a lunar orbit at that point. And then the plan is to launch at least one of these every year as part of an ongoing program. So where is that ongoing program taking us? The idea there is, I'm going to skip this. So the idea there is to build what we call a deep space gateway, basically a spaceport in the vicinity of the moon, so that you could launch deep space transportation missions from there, as well as missions to the lunar surface. And so it's kind of a build-up program approach where you would build up this spaceport over time, over several missions going there. You could start to do missions on the lunar surface, and while you were there, you're building and demonstrating the new technologies that you're going to need to live much farther away from the Earth. But in this location near the moon, you're only a few days away from home if something goes wrong, or you need, new equipment resupply, so you can really work out all the kinks before you go off to somewhere like Mars, where you're months and months away. So that's the idea behind building a deep space gateway, is that you could then, once you really thought you were ready and you had your deep space transportation system built, you could then live in lunar orbit for a whole year to really make sure everything was working properly. And then once you really believed in all of your systems, all the kinks had been worked out, you could then, of course, head off to Mars or other parts unknown. So that's the cartoon of us hopefully going to Mars one day. And so again, just to kind of run through the overall plan, where we are now and where we're heading, we would call a current time frame Earth reliant, because even though we have people living in space, all of their equipment, everything comes up from the Earth, and they're reliant on the Earth. Really, the ground controllers fly the space station, they're operating it. And so now through kind of the mid-2020s, we expect to continue to run the International Space Station, to continue to investigate, our human systems and how they function in microgravity, and how we can generate countermeasures to keep us healthy in space, as well as investigate new technologies that we can then take beyond low Earth orbit. And again, those are things like, how does your life support system work? How does your food system work? How does your toilet work? All of those things that are really important for when you go away from your home planet. And of course, we're working with commercial companies as we do this development, not just with the vehicles, but also with the science program that we're running on the space station. So the International Space Station is a national laboratory, so lots and lots of people can apply to have their research conducted on board the International Space Station, and we get all kinds of neat projects coming up there. We have a 3D printer, we have all kinds of really interesting cutting-edge programs, and interestingly, in the past it was very, very difficult to get a project on board the International Space Station because of all the vetting that was done beforehand, and the idea now is to kind of reduce some of that vetting. Now a project might not work, maybe you didn't think of something to make your project work in microgravity, but the wait period is much smaller, and so the turnover is much higher, and we're getting a lot of really high quality, very interesting projects coming through that way. And then moving on from the International Space Station, we would be in lunar orbit, and we call this the proving ground. And so again, regular crewed missions in the moon area. And again, you could potentially, you could have a company that was interested in doing something on the lunar surface. You could have another government, another country that was interested in partnering with you. So the idea is to continue to build these partnerships as we move on out of low Earth orbit. And then the final phase, or the next phase I'll say, would be sort of more Earth independent, that we could be established on the Martian surface. Of course, we have rovers already there doing exploring. We'll continue to explore those areas, and more robotic missions, sample return missions, that kind of thing, hopefully sending some humans to Mars in the early 2030s. So when I look out and I see kids in the kind of 10 to 20 age range, these are the folks that I look to think about. These are going to be the first boots on Mars, or the kids in that age range. And so if it's something that's at all interesting to you, whether you think you want to be that person on Mars or you want to just be part of that, lots and lots of skills are necessary to doing a project like this. Lots of really smart people are going to be needed to solve this kind of problem. So that's what I think about when I look out and I see you guys. And I know that probably some of the parents are wondering, well, okay, so I've seen this picture of this high school kid. How did you get from that kid to this bigger kid, we'll say? That's a question I often get from parents, and I know my mom probably still asks herself that question every day. But so of course the answer is education. I am a California girl, as I told you already. I went to UCLA, and I actually studied aerospace engineering because I knew I wanted to work for the space program, and I didn't think I'd get to be an astronaut. But then I kind of took a left turn into ocean engineering. I got involved in this kind of project. And the reason I put this up here is because as you look to your own education and your kids' education, the kinds of things we need to be able to do, it requires hands-on problem-solving skills. And so it's not enough just to read your textbook and to do your homework problems. You have to figure out how to think on your feet, how to solve problems real time, how to answer questions that you didn't think were going to be asked, all of those things. And you get those skills from building things, basically, from solving problems, using your hands and thinking through things like that. This was a water-filled submarine, so all kinds of skills when we had to be able to build it. I had to learn to scuba dive in order to drive it, and we raced it, not very successfully, but we learned a lot doing it, so it was a great project. And I took that left turn into ocean engineering and ended up at the Scripps Institution of Oceanography. And again, this kind of shows what I term that operational environment. So there's a lot of book learning, there's a lot of computer programming that you need to do, but you also need to be able to do the hands-on problem-solving part of it. And so, if you like working on cars, for example, or you like building things, those are the kinds of skills that we're going to be looking for when we're sending people on to somewhere like Mars. You need to be able to do it all, and you need to be able to communicate it, and you need to be able to work with a team. So those are the important skills. And I also get the question about, you went aerospace, oceanography, back to space, and for me it's all about exploration, right? It's that love for exploring, for answering the hard questions, for wanting to get to the top of the mountain to see just what's on the other side, and we're exploring our own planet in oceanography, 2/3 of the planet covered with oceans, and as things change for the oceans, that changes everything for us. And so that drive to solve those problems, again, we use technology to solve those problems. There's a lot of similarities between ocean-going research and space research. So for me, it's about exploration. And so the ultimate test, really, of all of this education for me was the 2 weeks that I got to spend in space, actually completing this mission and being part of the team that fixed the Hubble Space Telescope. And I just wanted to show my UCLA sweatshirt one more time. So, but it's great for me to look out here and to see kids that are interested, boys and girls that are interested in space flight and maybe in going to Mars one day, or maybe just working in mission control, or maybe being a scientist that's proposing an experiment to be flown in space to try to learn more about how the human body works, or how the universe was formed. There's just so many important questions. And so so if you're an adventurous person, if you're hardworking, determined, curious, all of those things are what's going to make you a great engineer and a great scientist and maybe a great astronaut one day. So if that happens for you, I hope you come back here and tell us all about it. So thanks very much. I think I got in time, and we have time for a few questions.
Here, I'll get another mic.
I have questions, so you guys.
All right, hands up. Let's see them right here. why did I want to go to space? So the question is, why did I want to go to space? And one of the reasons I kind of touched on a little bit is that when you're in space, you have to do a lot of different things. You have to learn a lot of different things. And I've always liked learning. And I like the challenge of having to be able to do a lot of different things. So plus the view is pretty good. It's a good view. Go ahead, you can pick. I just was getting wrong.
Why do you why did you live underwater for some time?
Oh, that's a good question. So you remembered that. So I lived underwater for 16 days, actually, and we do that, we call it an analog mission. And what that means is it's hard to go to Mars. We haven't done it yet. So how can we practice a mission as if we were on Mars? So we lived underwater in a habitat, and every day we would go out and we called it a spacewalk, but we're wearing dive equipment. And so we're walking around on the bottom of the ocean, and we're studying coral reefs, but we're then communicating back to a mission control center with a time delay. So if you go to Mars, it's going to take 15 minutes for your voice to get to Earth, and then 15 minutes for their answer to get back to you. So we were looking at how do you do science if you have questions? What am I looking at? What do I sample? My tool is broken. You have to be able to solve some of those problems on your own, and then figure out how to communicate what help you need to the people back home. So we're pretending like we're on Mars, even though we're underwater. That's a good question.
What's the craziest thing that happened to you while you were in space?
The craziest thing in space. Probably the most alarming thing that happened was on my way into space. And so we were sitting on the launch pad, and when you're practicing to go into space, your trainers break everything they can think of. And you have some books that tell you what to do in all of these different cases, and you're throwing switches and you're talking together, figuring out what to do. But you expect when you really launch into space that none of that's going to happen. But when I launched into space, as soon as the solid rocket boosters lit, we had a master alarm, which is a really loud dee-doo, dee-doo, and so it's very alarming, as you might expect. And it was a real failure. We had a wire that shorted for one of the control systems, and so fortunately, because NASA does everything in redundant systems, meaning you have more than one thing to do every job, we had 3 more systems that could do that job. But now you're starting to think, well, what else is wrong with this vehicle that they gave us, right? This is like a sim. And 2 minutes later, sure enough, we had another caution that told us there was something wrong with one of our main engines. And fortunately, in that case, it was not real. It was a sensor that had failed. And so the computer thought there was a problem, but there wasn't really a problem. So that was probably the craziest thing on my way into space.
Okay, I'm going to take this guy right back here.
Has there been any successful plant experiments up in space?
Any successful
Plant experiments.
plant experiments? Absolutely. So people have been growing plants in space for almost as long as there's been people in space. But most recently, with the veggie experiment that I showed you a picture of, starting last year, I think early last year, they were able to start eating the lettuces on board that they were growing. So that was exciting for them to be able to, have some fresh food.
Farm to table. Okay, we're going to take 2 more questions. I see right over here.
I always hear that when you get shot up in a space shuttle or in rocket, right, all your blood goes on the back and things like that, right? And then it takes quite some time before you regain consciousness, right?
So when you launch, when we launch on this, is that the rest of your question? Is that
No.
everything? Okay,
So
keep
my
going.
question is, I also hear that as you exercise or practice that on Earth with the G machines and all that, body gets better at it to cope up, right? So my question is, why does that happen? I mean, why should practicing defy the physical law of blood getting pushed out?
Okay, there's a lot of great questions. So I'll try to go through it quickly. When you launch into space, you don't lose consciousness. You're on your back because you're going to start to pull a G load through your chest. And you pull about 3 Gs, which you've probably seen fighter pilots will pull up to 9 Gs, but momentary Gs. And we're getting 3 Gs through the chest for about a minute. So it feels like an elephant standing on your chest. It makes it hard to breathe. But you don't lose consciousness because of your body position. So what I think you're referring to, once you get into space, you have a fluid shift because gravity's no longer pulling blood into your legs. So you get a fluid shift and you have too much fluid in your head. So your body says, I have too much fluid, and you start downloading a whole bunch of fluid in the usual fashion. And so then when you come home, you have less blood volume in your body than you should. And so if you were to just come from microgravity back to 1G, all the blood would come out of your head into your legs and you would pass out. So what we do is we wear what's called a G suit, which is something that fighter pilots wear as well, and we increase the pressure on the muscles in our legs, and it pushes the blood up out of our lower body into our upper body so that we don't pass out. So what you're talking about, the practicing, and this is something that pilots do as well, is called a G straining maneuver, and it's basically just learning how to counteract the flow of blood into the lower part of your body, and you're basically just clenching those muscles and trying to, basically hold that blood where it is. So that's why practicing can help. You're not actually, you're somewhat reversing that physical sensation, but you're not completely. So the G suit also helps.
Okay, last question, right here.
Have you ever thought of being an astronaut when you were a kid?
Did I think of being an astronaut when I was a kid? You can see my family's kind of nodding their heads over here. So this is my mom and my sister and my nieces right here. So probably for me, the first time I really thought seriously about it, I was in high school. I lived here, and we lived on a military base that shared space with the Ames Research Center, the NASA Ames Research Center. And so I would see astronauts come and park their T-38 jets and get out in their fancy blue suit and come in to practice landing the space shuttle in a simulator that they had. So I thought that looked like a pretty good job. But I knew it was kind of a long shot that I would ever get to do it, so I wanted to study aerospace engineering so that I could work for NASA someday. But yeah, I started to think about it when I was probably about 14 or 15. You're getting a head start, I can see.
Okay, unfortunately, that's all the time we have for questions. I want to one more time thank Raj and the Yahoo Employee Foundation, who really made it possible for us to bring Megan here today to give this talk, answer your questions. Can we get another big round of applause for Megan? If you guys would like to meet Megan and get a commemorative signed astronaut trading card and take a photo, we're going to be over by the cafe. We're going to be signing cards. We're going to be greeting. So come see us over there if you'd like to say hi. Thank you guys so much for coming and so much for your patience.